Okay, let's take a look. Again, click those all the way closed. And this should be pretty short today. I want to look at the second section of, second part of 3. Actually, hold, is this second part? I think so. Second part of 3.2, yeah. On evaluating functions. So, we know what function notation is. Just real quick, if I wanted to take this equation of a line, and I want to write that in function notation, what is it? What's the only thing I need to change to make that function notation? It looks pretty much the same. But I'm gonna say it again. F of x, yeah, right? F of x, that's function notation. And the way that we say that again is f of x. It's not f times x, and you're familiar with this. You've seen this many, many times. Function notation serves the same purpose. I mean, it's the same equation, but it's meant for a different context. Function notation always reminds us what the input variable is, because it's always the variable that appears in parentheses. So x is the input. The function is going to operate on that input. It's got some recipe. It's got some, we call it a rule, that it's going to follow. We're going to multiply by 2 and then add 7 to calculate the outputs for those inputs, right? So x is the input. And what's the output? Y, but what are we calling it now if it's function notation? F of x, yeah. So x is the input, and f of x, it calculates the output, right? We apply that rule and it calculates the output. So for example, if how would I say that? Yeah, we've talked about this. F of -3. And how would I calculate that? Yeah, it just tells me that's the value of x that I'm inputting. So I'm just substituting -3 for all the x's, right? And so f of -3 just becomes 2 times -3 plus 7, which we would simplify and get what? Come on now, let's go. 1, there you go. So then that tells me that I've got an ordered pair. What is the ordered pair associated with what we just did? Yeah, everybody see that? We're inputting a -3, and that's outputting 1. So it would just correspond to the point -3, 1, right? If I were graphing this function, that would be the point on the graph that corresponds to f of -3. So this is, I mean, we'll just zip through this real quick. I don't want to take too much time on this part. F of 3/10, if they're defining f of x as this linear equation, and they're defining g of x as this quadratic equation, and we haven't even talked about quadratics yet, but that's all right. It tells us what the rule is. It gives us the equation. What would I do to calculate f of 3/10? What am I doing there? Sophia, what am I doing there in number 2 if I want to calculate f of 3/10? Okay, I'm just plugging that in, right? Exactly. And we have some technology that we've already become well accustomed with. We have some technology for doing this and not having to crunch through doing all the arithmetic involving fractions. I would just put this in Desmos, and I would just literally define f of x as -5x minus 14 and then substitute f of 3/10, and it'll even do all the simplification for me, right? And when all the dust settles, we would just get -31/2. Okay? What about something like number 6? What about that? How would I say that, number 6? What's going on there? Somebody different. Be brave. Colt, what's going on with number 6? What's your first impression of that? Exactly. That's what we're trying to calculate, 2 times g of 12. How are we going to approach that, do you think? What are we going to do here? Ideas? Yeah, exactly. First thing we're going to do is we have to calculate what g of 12 is. And they give us, you know, the function g of x. So I'm just plugging 12 into that function. Okay, the important thing about problem 6 is that when you see something like g of 12, what you're thinking is, oh, that's just a number. That's just some output number that I can calculate, right? And we'll have to do that, but this is really just 2 times the output number. Oops. Two times the output number g of 12, which I just have to calculate, right? It's just some number, just some number. So we calculate it. If I plug 12 into my function, you know, what's going to happen there? I get negative x squared plus 9x minus 1. What was our rule when we talked about, you know, evaluating? We've talked a little bit about this already, about evaluation, right? What did we do? Well, we want to plug in the value. We always want to put it in parentheses because then we avoid making order of operations mistakes. So I'm going to put the 12 in parentheses. What would I do first? Let's assume we're not using Desmos. This is just good practice on simplifying using order of operations. What do I do first here if I'm going to simplify that expression? What do you mean distribute? That negative sign to the 12, can we do that? What do we have to do here? We got to be careful with that. We got to follow PEMDAS. If you think PEMDAS, distributing is multiplying, right? What comes before multiplying though? Exponents, yeah. So first I've got to do the 12 squared, right? What is 12 squared? 144. Then I can distribute the negative to the 144. Okay, good. So first we got to do that. We can multiply here. 9 times 12 is 108. So now I just have a bunch of terms that I'm going to add up. Negative 144 plus 108 minus 1. And if we do all that, we get negative 37. But we're not done because all we did was calculate g of 12. The original problem asked us to multiply 2 times g of 12. So I get 2 times negative 37, which is negative 74. Okay, makes sense? So anytime you see something like that, you see function notation where I'm actually inputting some number into a function, then that just represents, you know, g of 12 just represents some output number, right? That I just probably have to go calculate, but it's just a number. You always think of it like a number. Okay, so I'm going to skip that. You guys, you'll get plenty of practice on that stuff on the assignment. Let's look at something like this then. So again, in your notes, just do a quick calculation here. And I'd like you to tell me what the coordinates of this ordered pair are. Negative 4 what? So bust out your notes. Grab your notebook. Okay, so everybody, what's my input number here? Negative 4, good. And I'm trying to calculate the output number, right? Okay, how am I going to calculate the output number? Evelyn, what am I going to do? Yeah, how would I say that? F of -4. There you go, good. So what did we get for that? I'm going to plug that -4 in parentheses in for x, right? Order of operations, what do I do first? Exponent. -4 squared is positive 16 times 4. 64 minus 3. There you go. So there's my output number. Okay, good. How would I go about doing number 11? If I want to simplify that expression, what would I have to do first? Seven minus q of 4.5. What would be your first step? What do we think? Avery, what would you do? What's that q of 4.5 mean? Just an output number, right? Okay, so I need to know what number to subtract from 7, so how would I do that? Yeah, calculate q of 4.5. Well, there's q of x. Q of x is some bizarre function. It's the absolute value of 3x minus x cubed. So I just have to plug in 4.5 and see what I get, right? And so if I do that, that's giving me the absolute value of 3 times 4.5 minus 4.5 cubed. So what would I do first to simplify? The exponent, 4.5 cubed, is going to give me some big ugly decimal, 91.125. Then I could multiply, right? 3 times 4.5. Then I'll just find that difference. I'll subtract. And I'm going to get some negative number, but the absolute values are going to make it positive. And there's the decimal I end up getting, right? So we had to crank out what's the output number. And now, what do I do with that crazy output number? Yeah, plug it, right? That's just 7 minus that. So what's the answer going to be? What's 7 minus that bizarre decimal, 77.625? Yeah, good. So negative 70.625. That's it. Okay. Okay, so now let's kind of look at how maybe we could use, we're going to use functions in a slightly different way. Look at number 14 here. They give us the function f of x. F of x equals 3x plus 19. So here's the definition of the function. If f of x equals negative 62, find x. What's different about that than what we've been doing? What do you think, Hayden? Yeah, are they giving us the input or the output? They're giving us the output this time, which is a little strange, and they're asking us to calculate the input. So how would I approach that? Okay, good. So now instead of plugging in a value for x, I'm going to plug in negative 62 for the output, which is f of x. And that gives us an equation. So once we get an equation, we can solve it, right? The only variable in that equation is x, so by solving for x, we're finding the input, right? We work backwards. We started with the output, and they're going to ask us to find the input. So what would the two steps be in order to solve for x, everybody? Subtract 19, good, and then divide by 3. Okay, good. So how could we do that with a graphing utility? And again, I still don't have we're still working on getting the TI emulator installed. So we'll come back and look at your TI-84s here at some point. But for now, let's just do this in Desmos. So any suggestions how I could use Desmos to deal with a problem like this? I mean, we did it algebraically, but there may be many instances where algebra is going to be really tough or even impossible, but we still want to be able to answer a question like that, where they give us a function and they tell us the output value and they want us to find the corresponding input value. So what do you think? Any ideas? What could I do there? Say that again? We probably could. Yeah, we actually probably could use table. It might be kind of tough to do, though. Tables, we got really good at that when we were using functions, when we were choosing input values and calculating output values, but this one is backwards. So I'm going to go ahead and put the function in first, and let's see what the graph looks like, and maybe that'll help. So f of x equals 3x plus 19. Okay, there's my graph. Now, what am I looking for on that graph again? Because every point, there's an infinite number of points contained on that graph. If I drag a point along that graph, it's just giving me, Desmos is giving me continuous readouts of the inputs and outputs, right? So what are they asking us to do in question 14 again? Find what again? Find x when f of x, which is just a fancy name for y, is equal to negative 62. So I'm looking for the ordered pair that has what? Say it again. They tell us something about this ordered pair already. What coordinate are they giving us? The y coordinate, right? So I want to find the point that has a y coordinate of negative 62, right? Everybody buy that? Okay, so then the question is just, how do we do that? How do we find that point? Because if I just try to drag this point along, it's unlikely, it's possible, but it's unlikely I'm going to get exactly negative 62, because notice that Desmos has to take little tiny steps as I drag this from pixel to pixel. And the odds are I'm probably going to skip over the one I'm looking for. So what could I do? Any suggestions? I'm going to show you, but I'm just curious. Anybody have an idea how maybe we could use this technology to come up with the answer? It's different. I can't just plug a number in for x because I don't know what that number is. Right now, if I wanted to, we're used to doing something like this. We're used to saying, what if the input value was negative 5? I can calculate f of negative 5 pretty easily. It just gives me an output right there. Okay? What if I want to graph a point in Desmos? This is kind of cool. I could do something like I can just write an ordered pair, like, for example, 2, 3, and look what it does. And I can even label it. It gives me the point 2, 3, right? Well, what if I want to find a point on a function? I could do this. I could do something. I've already defined the function, so I could plug in negative 5, and I could let Desmos calculate the output using f of x, because I've already communicated to Desmos what f of x is. So for my y coordinate, I can just do f of negative 5, and hey, look what it does. Right? I don't even have to calculate what f of negative 5 is. It will determine what that ordered pair is, and it'll plug it in on Desmos someplace on that line. That's where negative 5, 4 is. Somehow I need to figure out the point that has a y coordinate of negative 62. Unfortunately, I can't just plug in negative 62 there. It doesn't do anything. Is there a way I could trick Desmos because by using its functionality, Desmos does some interesting things. Like, for example, if I put in another graph, like what if I put in y equals negative x plus 3 or something? If I zoom in here, everybody see those, like if I click on the purple line, everybody see that Desmos has these grayed out points? Why did it choose those? It has an infinite number of choices. How come it chose to highlight those 3 places? Okay, so I got an intercept, x-intercept, a y-intercept, and an intersection, right? Desmos is pretty smart. It knows the kinds of places we're going to look for, and it makes it easy for us to calculate intersections. If I want to find the place where the red and purple lines intersect, I just click on that point, and it's going to give me the ordered pair. Okay, so could I use that functionality to trick Desmos into giving me the ordered pair that I want, which is when y equals negative 62? Is there a different function maybe I could input other than I just made up y equals negative x plus 3? Is there one whose intersection would be useful to me? Any ideas? Oh, what about that? What if I choose the line y equals negative 62? What kind of line is that going to be? Horizontal line, and what are the y coordinates going to be of every point on that line? Negative 62, including oops, I got 2 negatives there, didn't I? Including that point right there. That's the one we want, isn't it? Everybody see that? Okay, that's the one we want. That's the one that tells us that when y is negative 62 on my red line, which is my function, x has a value of negative 27. Okay? And something you can do in Desmos, when it gives you, this is kind of some new functionality, when it gives you that little icon right there, I don't know what you'd call that, it's kind of an arrow pointing into a box. You can click on that and it'll export that point right into your list of items that are being graphed. And there it shows up. Okay? So this is a really good use of Desmos. Let me take a picture of that for our notes. You can refer back to this. And let's see, I'll put, there it is for your notes. Okay. So now let's take a look at a situation where we're using a function that represents something. So Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. Okay, first of all, I should have probably covered that up. Can you guys make a function then, right? If we're going to say P of T represents the total amount of money he's paid after T months, so what's our input variable? What is it? T. Okay, what does T represent here? Months, because we don't know. I mean, they have to tell us. T could represent minutes or hours or something, but no, it represents months. So what would our function be? And we're going to review this stuff when we start talking more seriously about, we start reviewing linear equations. But if the initial payment is $108 and he's paying $74 per month, what would that be as an equation, do you think? That? There you go, 74T plus 108, isn't it? Right, how do you know that? What gives away that $74 per month is a rate, so it's getting multiplied by the input? What word? Per. Yeah, there you go. Per tells us it's a rate, doesn't it? Good, so we end up with, whoops, 74T plus 108, or they mixed it up, doesn't really matter. What does P of 24 represent? I don't want an answer. I just want to know, what does that mean, first of all? Say it again. Payment after 24 months. Yeah, how much has this guy paid this landscaping company after 24 months? And how would I find that? Plug it in, right? That's just using a function to evaluate a value. We're just evaluating a value of t. So P of 24 equals 108 plus 74 times 24. How could we multiply that, do you think, in our heads? What could we do? If you really wanted to. This is good practice. This kind of mental math makes you better at algebra. How could I multiply 74 times 24? A couple ways you could do it. Any ideas? What would you do? No wrong answer. If you wanted to do that mental math, what could you do? What do you think? When you're doing big numbers like that, a lot of times it's good to break it into pieces. So I could break up, for example, I could break up 70, or I could break up 24 into 20 plus 4, right? And do 20 times 74 plus 4 times 74. And those are, I mean, I have to kind of think about those a little bit, but I could do those. There's another way you could do this one too. What if I did something like I thought, okay, 24 times 75 wouldn't be too bad, right? 24 times 75, how could I do that one? This is just, I mean, I know these are good strategies though. It's good to kind of think about this stuff. Wouldn't 75 times 24 be the same as 150 times 12? Everybody buy that? Right? And I don't want to spend too much time on this, but I think with a group like this, it's kind of good to talk about this. What if I did something like I wanted to do again, 75 times 24? That's the same thing as 75 times 2 times 12, which is just 150 times 12, right? Which is the same as 75 times 2 times 2 times 6. What's all that equal? 75 times 2 is 150 times 2 is, okay, now this is getting easy. What's 300 times 6? That's pretty easy. Yeah, that's right, that's just 1800. So if 75 times 24 is 1800, what would 74 times 24 be? How much less is that? 24 less, yeah, because 74 times 24 is literally 74 24s. 75 times 24 is 75 24s. So I could calculate it for 75, which is pretty easy. I mean, if you kind of break it down like this, once you start to think about these things a little bit. And then I just got to subtract away one of those 24s and I got it, right? So that would just be 1776. So you can, I mean, if that seems like a long process, but I would challenge you to kind of a little bit every day on one of your assignments, just kind of think about how you can do some mental math here. Because why would I ask you to do that? If you look at real-time imaging of a person's brain when they're doing mental math, you use a lot of your brain to do that. It makes you smarter, for one thing, but also the pathways you use are very similar to the ones you use when you're doing symbolic algebra, abstract algebra. So by getting better at this, you get better at the mental connections that are going to help you with algebra as algebra gets more difficult. Anyway, we could just plug all that in and get an answer though, right? So we got 1776 plus 108. Well, that's 1876 plus 8 is what? Plus 8, right? What is that? 1884. There you go. So what's that tell us? Let's not get lost in the mental math here. What did we just do? What's P of 24 again? Oh, how much he paid after 24 months. Okay, good. Good, good. All right, so how about part B? How long has Owen been receiving lawn service if he has paid a total of $2,994? What are you going to do there? What is $29.94, an input number or an output number? Output number. Okay, so jump into Desmos and Desmos graphing and see if you can find that answer. Help each other out. I mean, we could do this algebraically, but go ahead and use technology.